Alright gang, last video for the week. Um, let's see what we got going on here. I know I have to get that in some form where we have like, well in this case it looks like it's going to be x squared minus a squared. Okay. Alright, so let's see, that would be the same as the square root of x squared minus 2 squared over x dx, where obviously your a here is going to be your 2. Okay, all right, so we go to this sheet right here. We say, okay, what am I going to use? Well, it's got to be this guy right here. Okay, so we're going to substitute for x, a, which is 2 secant of theta. Okay, so x equals 2 secant of theta. Okay. All right, so let's see. So my derivative of x, or dx, the derivative of secant is secant tangent. So it's secant theta, tangent theta, d theta. Okay, so we're going to substitute that stuff in there. Okay, so let's see. Up top, x is 2 secant of theta. Okay, so this is 2 secant theta squared minus 2 squared, and then down below notice I have x again. Well, x is 2 secant of theta. Okay, times my dx, which is 2 secant theta tangent theta d theta. Okay, so right off the bat notice I get some stuff to cancel off. I get this 2 to cancel with that 2. I get this secant to cancel with that secant. Okay, all right, so let's see. The denominator goes away, just becomes 1, so we just drop it. Okay, and let's see, in the radicand, I have a constant multiplier of, or a GCF, depending on how you want to call it, of 2 squared. So I'm going to pull that guy away. And then I'll have secant squared minus 1. Okay, and let's see, what am I left with here? Tangent theta d theta. Okay, so secant squared minus 1, going to your Pythagorean identities, okay, on this guy, secant squared minus 1 would be equal to tangent squared. Okay, so we substitute tangent squared in here. So I have the square root of 2 squared times tangent squared theta. All right, times, let's see, tangent theta d theta. Okay. All right, so let's see, this is a perfect square here. So I take the square root and I get 2 tangent of theta times this tangent of theta d theta. Okay, so I got a constant multiplier of 2, so I'll pull that out front. And I'm left with tangent squared theta d theta. Okay, so if we go to our list right here, we do not have anything for tangent squared. Okay, but I'm thinking maybe we need to use our Pythagorean identity. Okay, so we know that this guy, let's see, I'm going to put it up here. We know tangent squared theta plus 1 equals secant squared theta. Okay, we know that. Okay, so tangent squared would be secant squared minus 1. Okay, so we get 2 times a quantity of secant squared theta minus 1 d theta. Now you say, well, why do I want to do that? Well, number one, we can integrate 1 d theta, and right here we can integrate secant squared d theta as well. Okay, so we're in good shape here. So we split this up into 2 integrals, and don't forget, both of the integrals will have a multiplier, a constant multiplier of 2. So that's 2 times the integral of secant squared theta d theta minus 2 times the integral of 1 d theta. Okay. Okay, so let's see what we got going on here. Okay, so when I integrate secant squared, I get tangent. Okay, so that's tangent of theta d theta minus, when I integrate 1d theta, I just get theta, so I get 2 theta plus c. Okay, so we have everything integrated, so now it's just a matter of getting rid of the thetas, okay, and getting it in terms of x. So let's see, that usually helps us up here. So let's see, if I take this top one, notice that I get x over 2 equals secant of theta. So that means that theta has to be equal to the arc secant of x over 2. So that'll take care of this guy right here. Okay. So let's see, minus 2 times arc secant of x over 2. That takes care of that guy. Okay, now tangent theta. Well, I think I have to go here. Okay, back to my Pythagorean identity. Okay, and tangent of theta would be the square root of secant squared minus 1. So we get 2 times the square root of secant squared theta minus 1. And you notice, I just noticed something here. Why do I have this d theta here? I don't know why I have that guy there. That guy shouldn't be there. We integrated already, so that d theta is gone. I have no idea why I left it there. Okay, so what can I do here? I've got something for secant. Okay, notice that secant is x over 2. So this right here would be the square of x over 2. Okay, so I get square root of x over 2 squared minus 1 minus this part of it I'm done with, 2 arc secant of x over 2 plus c. So now it's just a matter of simplifying that. Okay, so let's see what we got going on. Square root of, well, this would be x squared over 4. So I'm going to get x squared minus 4 all over 4. Okay, 2 arc secant of x over 2 plus c. And then notice when I take the square root of the numerator and the square root of the denominator becomes 2, and that cancels with the 2 out here. So I am just left with the square root of x squared minus 4 minus 2 arc secant of x over 2 plus c. Okay, I kind of like that guy. Let's see, is that what I got when I did it this morning? Let's make sure. Where'd my guy go? Yes, it is. Okay, so we're in good shape, so feel good about that guy. Let's do one more of these guys. And I thought, why don't we take one where your A ends up being a radical. Okay, yeah, it's a little bit tougher, not a whole bunch. I did it this morning, it comes out just as easy. Okay, so if we start this the same way, okay, and I'm gonna write that as x squared minus radical 6 squared over x dx. So I know right here my A ends up being radical 6. So somewhere along the road we may end up having to rationalize, but I'm going to leave that all the way till the end, okay? And I'm not going to worry about it right now. Okay, so again, going to our sheets of information once again. Okay, we've got x squared minus a squared, so it's right here. So again, we have to put in x has to be a, which is radical 6 secant of theta. Okay. All right, so let's see. Our x ends up being radical 6 secant of theta. Okay, so our dx ends up being radical 6 is just a constant multiplier, and then the derivative of secant would be secant theta tangent theta d theta. Okay, so I do my substitution, and let's see, up above, okay, my x is radical 6 secant of theta, that's squared, minus radical 6 squared. Okay, down below that, x is radical 6 secant of theta, and then my dx is right here, radical 6 secant theta tangent theta d theta. All right, so again, I get this to go away with that, and I get this secant of theta to go away with that secant of theta. So the denominator here just becomes 1, so we can just toss it. All right, so let's see. In that radicand up above, I have a GCF of radical 6 squared. I can pull that out, radical 6 squared, and I'm left with secant squared theta minus 1 times, here I'm just left with tangent theta d theta. Okay, so we know that, again, just like we did with the last one, from your Pythagorean identities, we know we're going to use this tangent squared theta plus 1 equals secant squared theta. Okay, this guy right here. Okay, so that's secant squared minus 1 would be tangent squared. Okay, so I get the square root of radical 6 squared tangent squared theta times this tangent theta d theta. Okay, so this radicand is a perfect square, so we take the square root, and I have radical 6 tangent of theta, and then I have this tangent theta d theta. Okay, so I have a radical 6, which is a constant multiplier, so I'll just stick that guy out front. And then tangent times tangent, obviously, is tangent squared d theta. Okay, once again, going here, I don't have anything for tangent squared, okay, but I can make this substitution from our Pythagorean identity, and tangent squared would be secant squared minus 1. Okay, so I get radical 6 times the integral of secant squared theta minus 1 d theta. Okay, and I know I can integrate secant squared and I can integrate 1, so I just split it up into 2 integrals. Remember that both integrals have the constant multiplier of radical 6 out front. Secant squared theta d theta minus radical 6 of 1 d theta. Okay, and I can integrate both of those. Okay, so when I integrate secant squared, I just get tangent. Okay, so I get radical 6 tangent of theta minus, when I integrate 1 d theta, I just get theta, so that's going to give me radical 6 theta plus c. Okay, so everything is integrated, so now I just have to go back and get things in terms of x. Okay, so if we take this guy, okay, I know I'm going to get x over radical 6 equals secant of theta. So that means that theta has to be the arc secant of x over radical 6. Okay, so that'll take care of this guy right here. So minus radical 6 times the arc secant of x over radical 6. Okay, so now I just have to come up with this guy. Okay, so we have to go back to our Pythagorean identity. Okay, so tangent would be the square root of secant squared minus 1. So this would be the square root of secant squared theta minus 1. Okay, so this part of it's done. Okay, let's see, I got radical 6 times the square root of, well, secant is right here, x over radical 6. Okay, so this would be x over radical 6 squared minus 1. Okay, again, I'm just going to bring this guy down because this is all done. Arc secant of x over radical 6 plus c. Okay, let's see. Radical 6, let's see, this guy right here. Well, that would give me x squared over 6, and this would be 6 over 6. So that gives me x squared minus 6 all over 6, and that's the entire radicand, minus radical 6 arc secant of x over radical 6 plus c. And then we say, okay, well, what happens here? Well, notice if I use the quotient rule here, I'd have the square root of x squared minus 6 over the square root of 6. So notice that square root of 6 down below cancels with this square root of 6. And so I am just left with the square root of x squared minus 6 minus radical 6 times the arc secant. Now right here, if you want to rationalize, go ahead. You can leave it the way it is. I'm fine with that. But if we rationalize it, okay, we're going to get x radical 6 all over 6 plus c. And we're done. I'd say the only other form of the answer is if if you just left it like this rather than rationalizing. I don't think it's that big of a deal. Okay, so there we go. That'll wrap it up for this week. The quizzes were posted yesterday, so you can get going on that. It's due again next Monday. You guys stay safe out there, and I miss you a whole bunch.